Hello students, welcome to another lecture. I am Dr. Saleha Jamal, Associate Professor from Department of Geography, Aligarh Muslim University, Aligarh. So, in previous lecture we have discussed what is spatial analysis, what are the different types of spatial analysis in which we have seen this, we have introduced the 6 different types of spatial analysis and importance of spatial analysis, that why we are dealing with the spatial analysis. In continuation to that lecture, now we are going to start with the components of spatial analysis, because without knowing the components of spatial analysis, we cannot proceed for the practical application of spatial analysis. So this lecture generally deals with the different components of the spatial analysis. There are 9 important major components of the spatial analysis, that is data acquisition, data pre-processing, exploratory spatial data analysis, that is in short that is known as ESDA. There are different spatial operations, spatial modeling, spatial statistics, spatial decision support system, that SDSS, revisualization and validation and interpretation. And after discussing these components of the spatial analysis, we will discuss about the spatial analysis processes, how we are going to proceed with certain problems, which are the steps is to be followed. So, starting with the components of the spatial analysis. The first and one of the most important component of the spatial analysis is data acquisition, that is acquiring data, collecting data, gathering data, and this acquisition of data is according to the problem which is to be solved. According to the problem, what data is to be needed, data acquisition is to be done. So data acquisition simply means gathering spatial data from various sources like satellite imageries. Satellite imageries are now, they can give a very fine data if we come to its temporal resolution, spatial resolution, radial resolution. For example, we are now, firstly we are getting a very coarse resolution imageries from 30 meters to 15 meters to even to 1 meter. So very fine resolution imageries can be obtained, giving the specific information. Data can also be acquired from the aerial photography, that can be taken through the hot air balloons, maybe from the aircrafts, maybe from the domes, etc. Data acquired from the GPS, through the different types of surveys, or even the data can also be acquired through the existing database, whatever the existing database is, which is used for some other purpose. If we need part of that data, so data can also be acquired from the existing database. So data acquisition is simply acquiring, getting the data according to the problem, according to the need, etc. we can say. So this is a step of data acquisition. It involves collecting both vector data. When we talk about the vector data, it means points, lines, polygon data, or raster data, that is grid data, attributes, features of those vector data, that is representing the geographic feature and attribute. So generally the data acquisition that includes the collection of both types of data, whether it is vector data or raster data. So it is one of the basic and the first component of the spatial analysis, because without getting the data we cannot proceed for further processes. Now, second important component of this spatial analysis is data pre-processing. Pre-processing the data which we have gathered during the data acquisition, that is somewhat we can say a raw data that is to be refined, that needs some cleaning, organizing the data, organizing in such a manner that it can be used for further analysis. So data pre-processing generally deals with the cleaning of, organizing data and preparing the spatial data for the analysis. This may include removing different errors, or if some inconsistencies can be data, that is to be removed during the pre-processing. We should harmonize data formats and projections also for soft and swift and quick handling. We should also handle missing values. For example, if we are acquiring climate data, many times the climate data for different time period is generally missing. So that can be that is to be handled in order to get there are different techniques to handle that data in order to get the continuous data. So handling of missing values is very much important through various techniques. There are various techniques present for handling the missing values. Then integrating all these data from the multiple sources which we have received for a particular purpose. Maybe purpose may be one, but data that we are using to solve that purpose may be acquired from the different sources. Maybe that data may be acquired from the GPS also, the data must be acquired maybe from the satellite imagery, maybe from the census data. During the pre-processing, what we generally do, we integrate all this data from the multiple sources into a one unified data set. So data pre-processing is very much important. It prepares the data, it readies the data for the further operations in spatial analysis. Without pre-processing, we cannot proceed for the further analysis because it prepares the spatial data for different operations. So data processing is simply cleaning, organizing or removing the errors, inconsistency, or even we can say missing values that is present in data. Now, coming to the third component, that is exploratory spatial data analysis, that is also known as ESDA. So exploratory spatial data analysis, in which exploring the data, we are going to explore the data, investigate the data, whether some sort of pattern is existing, whether some sort of trends are existing, maybe positive trend, negative trend, whether in this particular spatial data certain types of relationships are existing, positive relationships, maybe negative relationships. It means we are exploring the data, we are investigating the data for certain patterns, trends, relationships, certain directional or proportional relationship, etc. So this process generally involves visualizing the spatial data, that may be using maps, we can visualize the spatial data, maybe using charts, maybe sometime graphs, maybe sometime we can conduct descriptive statistic analysis to identify whether certain clusters are present. For example, for crime rate, where the particular crime is only existing in a particular location, that is what certain clusters are present. We can even investigate, we can even explore the trends, the hotspots. For example, for assessing the microclimate of a particular place, if a certain location is showing a higher surface temperature, very high surface temperature, why this particular hotspot is existing, whether it is barren land or whether it is some sort of, we can say, dumping sites or very dense built up space, or what. So investigating the data for certain cluster trends, hotspots, and many times also investigating to find out certain types of spatial autocorrelation. So in this, just we are visualizing, exploring and finding out certain types of patterns, relationships, clusters and all by using different types of maps, charts, graphs. So that's why it is known, this component is known as exploratory spatial data analysis, that is ESDA. After exploring and investigating certain type of pattern and all, we move to another component that is known as spatial operation. When we talk about the spatial operations, certain spatial operations are performed on the spatial data, like performing geometric and topological operations on the spatial data to which we are dealing with. This may include various tasks like buffering processes. Buffering is simply what? If we are having certain location, for example, if there is a waste disposal site, certain waste disposal site is there, and we want to find out the impact of this waste disposal site on the residents living around its vicinity. So we can draw a boundary buffer at certain distance. For example, if we are taking the distance of 500 meter, then another 500 meter will make 1 kilometer, and then another 500, at 1.5 kilometer, means 3 zone can be buffered at 500, 1 kilometer and 1.5 kilometer, in order to see the impact of that waste disposal or dumping site on the population living around that, to order to know the effectiveness of, we can say, that particular waste disposal site. So in spatial operations, like buffering can be done, intersecting can be done, overlaying can be done to find out certain, if we are dealing to find out the suitable site for the something, we can overlay different types of features on one another to get the suitable site or suitable locations for something, we can say. Clipping is also one of the operations. Splitting geographic features is another very important operations. These all operations are generally done to create a new data sets to derive spatial relationships. These spatial operations to which I talked about, that is buffering, intersecting, overlaying, clipping, splitting, etc., that will be discussed one by one in the next lecture. So here spatial operation is one of the very important component of spatial analysis, in which generally the geometric and topological operations on spatial data is performed. Next comes the spatial modeling. Another components of spatial analysis. Spatial modeling deals with the spatial unit. Certain models is to be used, and now the spatial models, that models may be some mathematical model, maybe some statistical model, or maybe some computational model can be used to simulate and even to analyze the spatial phenomena. For example, for the land use land cover, to find out, simulate the future land use land cover, we can use the model like Markov model to simulate the future of land use land cover map. So by applying that model, we can predict the future land use land cover. There are different types of models, and we can say even the statistical, mathematical and computational model. One I have named like Markov model. For the statistical models, we can say an analytical hierarchy process model, that is AHP. These are the different models which can be used. There are certain predictive models are also there for the future predictions. There are spatial regression models, there are spatial interpolation models, or even we can say agent based models to understand the different spatial processes and make predictions. For example, during the interpolations, if we are having the point data, suppose we are taking air pollution, we are monitoring air pollution. In air pollution, we will have certain point data. In that point data, for the particular boundary or space, we can interpolate the air pollution by running to that certain model. Even for example, the Russell model can be used in order to assess the soil erosion rate. So different models can be used in order to simulate and analyze the spatial phenomena. So this is also one of the very important component of spatial analysis. If we are moving to another component, that is spatial statistic. Like spatial model, spatial statistics is also very important. Applying statistical methods are generally applied to analyze spatial data patterns. This includes techniques such as, we can say, various spatial autocorrelation analysis, spatial regression analysis may be used, cluster analysis may be used. For example, I have said to find out the crime rates, why a particular crime rate is found in a particular place compared to the other cluster analysis can be used. Spatial interpolations, nearest neighbor analysis can be used for interpolating that. Point pattern analysis to quantify various types of relationships to infer get some statistical significant results. We can use different types of spatial statistics. So similarly, like what we have discussed in spatial model, similarly this spatial statistics techniques can be used to get a useful insights from the spatial data. Now coming to the another important component, that is spatial decision support system, that is SDSS. If we talk about this spatial decision support system, it is somewhat a bit different what we have discussed earlier about the spatial component, because in this designing and implementing system, we generally design and implement systems in order to assist decision making in particular spatial context for particular spatial phenomena. So here we are going to design and implement these systems for what purpose? Generally to assist the decision making for the spatial context. This involves integrating the spatial analysis tools, what we have discussed earlier. There are different types of spatial analysis tools. We can integrate these analysis tools with data visualization techniques and also use various interactive interfaces in order to support the stakeholders in finding out the alternatives, in evaluating the trade-offs and selecting the optimal solution. So the spatial decision support system is generally an assisting component for certain spatial context, we can say. Coming to the revisualization, when we are talking about the revisualization, simply visualizing the spatial data and analysis result to communicate the insights, what the insights we have received in effective manner. So revisualization, getting the results and communicating the results effectively to the users, to the person concerned. So this include revisualization includes creation of maps, charts, graphs or various interactive visualizations to present the spatial patterns, trends, relationships and to convey the complex spatial information to various diverse audience in a simple and easy way. Because if we are dealing with the complex spatial data, so we can convey the information insights which we have received from this complex spatial data more easily through the graphs and through the maps, charts or by mapping the certain spatial patterns, finding out the certain trends and relationships. So these are all aspects are related to the revisualization components of spatial analysis. Now coming to the validation and interpretation. Once we have completed the spatial operations and all, the work is not complete until it is validated, well validated and well interpreted. So assessing the accuracy, similarly for the satellite images, you must be knowing, students, that we go for accuracy assessment. There are different methods, Kriging methods, where we can use the kappa coefficient method for the accuracy assessment. Similarly, here what we have received the result, the validation of those results becomes very important. How much reliable results we have received, what is the validity of that spatial analysis result. So this will involve comparing the model predictions with the observed data. For example, if we have predicted the future land use land cover through the Markov model, so validation is to be done by running the spatial data of land use land cover present data in that particular model, and once that result is obtained, that is to be compared with the observed data. Then only we can rely whether the future result we have obtained through certain model is correct or not. So comparing the model predictions with the observed data, we can also conduct sensitivity analysis. We can have interpreting findings in context to the domain knowledge. We can discuss it with the person having expertise in that particular field, and the stakeholder. We can take the input of the different stakeholders related to that. So while going through these components, by integrating these components, the spatial analysis enables the users, enables the analyst to gain more deeper insights into the spatial phenomena we are dealing with. It also not only helps to get the deeper insights, but also support evidence-based decision making. Evidence-based decision making and address complex spatial problems across various domains, including urban planning, environmental management, transportation, public health, various natural resource management and all. The applications will be discussed in another lecture, which will be dealing with the only application part of the spatial analysis. Once completing the components of the spatial analysis, there is very important thing which need to be discussed, that is spatial analysis process. When we are not going through the particular planned and we can say step by step process, if we are missing some step while performing the spatial analysis, it is bit obvious that it will affect the accuracy of the result which is obtained. So in spatial analysis, we have different steps. For example, the first step is planning. We know planning is what generally in day-to-day life we also plan what to do, how to do, when to do, and these all things we plan for certain operations. Similarly, in spatial analysis also, we have to plan what is the need, which problem is to be assessed. We have to choose the problem that is to be addressed. What goals we have to achieve for this problem, that is to be planned. Through which objectives we can achieve this particular goal, that is to be planned. What are the methods is to be used for solving which type of data we need for this particular problem to address. Means defining the goals, objectives of spatial analysis, identifying the spatial questions to be addressed, and plan overall approach comes to the planning. If the planning is good, then the next operations, the further operations will go smoothly and quickly. The next after plannings in a spatial analysis process comes the data gathering. Data gathering, we know in spatial analysis, without gathering spatial data, we cannot move further. So it is one of the very important spatial analysis process, that is data gathering, in which we simply acquire different spatial data that is required for the analysis from the various sources, maybe from the field surveys, maybe we can gather data through existing data sets, maybe from the remote sensing operations. So the data gathering is one of the very important process, because without gathering spatial data, we cannot perform the spatial analysis. So once we have gathered the data, we have to move further to the another step, that is exploratory analysis. We have to explore the data, we have to investigate the data, we have to conduct some sort of initial exploration of the spatial data to identify different patterns, whether any sort of pattern is existing in data, any sort of anomalies is existing in the data, or any sort of potential relationships are existing in the data. These all things comes under the process of exploratory, because whenever we are having the spatial data, we visualize, we explore the things, and at a glance many times we can find out that particular trends can be seen with the time. For example, with the time temperature is increasing, a sort of trend can be seen, increase in temperature with time, decrease in certain resource with increase in population. Some trends are the same. This is what? This is the exploratory analysis. So we have to go through this process. After only having the exploratory analysis, we can have another step, hypothesis formulation. Without exploratory analysis, we cannot move for hypothesis formulation. Previously I have told, a hypothesis is simply an idea or giving an explanation for something which is not yet been checked whether it is correct or not. So this hypothesis formulation, we can say developing hypotheses or even the theories based on certain types of patterns and observations which we have seen in exploratory analysis, can only be done after exploring and investigating the data. So this hypothesis, development of hypotheses and theories based on different observations, patterns, trends is identified during the exploratory analysis. So these both are interrelated. Without exploratory analysis, we cannot move for hypothesis formulation. So after hypothesis formulation, modeling and testing. What I have said, hypothesis is simply giving an idea or explanation of something which has not yet been tested. So for that we need certain model, certain techniques to test that hypothesis. That we have to apply spatial techniques to test the hypothesis which we have formulated and simulate the spatial processes. The statistical and spatial models can be used for this purpose, modeling and testing. I have named previously various models and even the testing techniques. If we go for testing techniques, we can have t-test, ANOVA test. For simulating, we have used different models like Markov chain models, etc. Now, after modeling and testing, we can move further for consultation and review. Consultation and review, whatever we have done, we have processed, we have the information we have received through the certain processes, that should be engaged with the certain stakeholders, that should be discussed with the experts of that particular fields or the relevant parties to gather the feedback on the analysis, models and the result. This will make our analysis and result more accurate, and this will also authenticate our result. So consultation and review, although many times some users used to skip this process, consultation and review, but if you are going for this process, consultation and review, this process will make our result, it will authenticate our result, and the accuracy of our result will be, it is a greater possibility that accuracy of the result will be also determined by engaging with the stakeholders and the experts or relevant parties in order to gather their feedback. Lastly, the last process is reporting and implementation. If we have, by doing certain spatial operations, by moving through the certain processes, if we have got our result, if we are not using it, if we are not reporting it, and according to the result we can also put certain suggestion for the implementation, then work is incomplete. So communicating the findings and the results of the spatial analysis is the very important process, because depending upon the context, recommendations can be implemented or used for decision making, because reporting and implementation is one of the important process with different policy makers, decision makers generally used for certain spatial phenomena. Different policy makers, decision makers, stakeholders, different parties or different institutions, organizations use this reporting and implement the suggestions, recommendation accordingly to make the space more resilient, more sustainable and more livable. Thus we can say, we can in end we can get the best result through the consultation and review and reporting processes. So all these spatial analysis processes, whether it is planning, whether it is data gathering, exploratory analysis, hypothesis formulation, modeling and testing, consultation and review, reporting and implementation is very much important. And if we move through these processes step by step, then it is the possibility, the result we are getting that will be much more accurate. And if we compare, if we are skipping the certain processes, the result that we are getting, that may be not up to the mark. So following these processes step by step is very much important. So dear students, that's all for today's lecture. We'll be meeting for the next topic in another lecture. Till then, have a good day. Thank you.